Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, how you hand Claude a brand new superpower by writing an ordinary Python function and adding one line above it.
Let's ground this. The setup is I understand MCP, the Model Context Protocol, the standard that lets any LLM client call external tools over the same wire format. What I don't want to do is write that protocol by hand.
And that's the entire pain FastMCP removes. Normally, to expose a tool, a client connects and asks your server, what tools do you have and what arguments does each take? And the answer has to be a precise JSON schema. Exact field names, types, descriptions. Writing that schema by hand for every function is tedious and easy to get wrong.
So FastMCP writes the schema for me. From what?
From things you're already writing. It reads your Python type hints and your docstring at import time and synthesizes the schema automatically. And this is the core bet of the whole framework. Your function signature is the contract the model reads.
Say more about that because it sounds almost too convenient.
Make it concrete. You write a function. Add takes a as an int, b as an int. Because you type them as ints, the model literally cannot pass a string for if FastMCP validates it and rejects it. And the docstring. Add to integers and return the sum. That becomes the description the model reads when it's deciding whether to even call your tool.
So if I rename a parameter or improve the docstring,
the schema updates instantly. Add a sentence of documentation, and the model immediately sees a richer description. No second file to keep in sync. The whole bet is that a well-typed, well-documented function is already most of what a good tool schema needs.
Okay, you keep saying tool. Is a tool the only thing a server can expose?
No. There are three primitives, and the distinction matters. Tools are actions the model invokes. It runs code and returns a result. Resources are read-only data the client fetches. A file, some database rows, a config. And crucially, the model doesn't call it like a function. It's addressed by a URI, like a little internal web address. And prompts are reusable message templates. Canned system prompts the server ships and versions, right alongside the code.
So if I just have a static config blob, settings, no side effects, I'd reach for a resource, not a tool.
Exactly the right instinct. Wrapping read-only data as a tool works, but it muddies the semantics and adds tool call overhead for no reason. A resource says, this is data you read. A tool says, this is an action with consequences. Keep that line clean, and your server stays legible.
And how little code are we actually talking end to end?
Your first working server fits in about 20 lines. You make a FastMCP object, you decorate a couple of functions, and at the bottom you call run. That's a complete, runnable MCP server. By default, it talks over STDO, standard in, standard out, which means the client just spawns your process. No port, no network, no auth to think about.
And if the client is remote, not on the same machine?
Then you switch to HTTP. You pass a transport and a port. And now your server listens for remote connections. Same functions, same decorators. You've just changed the doorway they come in through. STDO for local, like Claude Desktop spawning your script. HTTP when something across the network needs to reach it.
So once it's wired up, what does Claude Desktop actually do with it?
You add an entry to its config pointing at your script. On startup, it spawns your process. Calls tool/list to discover everything you expose. And then invokes your tools mid-conversation exactly as if they were built in. To the model, your custom function and a native capability are indistinguishable.
And that's the part I'd want to slow down on. Because it'll just call my tool, no confirmation. If that tool writes to a database, it writes.
You've landed on the exact thing to be careful about. The model invokes your tool without a second prompt, and it constructs the arguments from natural language. So weird edge cases happen. Two rules keep you safe. 1. Scope each tool narrowly. If a tool only needs to read, do not hand it write credentials. 2. Validate inputs yourself. even though FastMCP type checks them, because the types don't catch a perfectly valid but drawing value.
And there's a subtle point hiding in there about the docstring, isn't there?
A really important one. That docstring isn't just documentation. It's the contract the model reads to decide how to call your tool. A vague description leads to vague, wrong calls. Precision in the docstring is precision in the calls. And before you wire up a real client, there's a CLI inspector. You run something like FastMCP dev against your server. That lets you poke at your tools and catch schema errors fast.
And the big payoff is that none of this is locked to one vendor.
That's the whole reason it's worth doing. MCP is a vendor-neutral open standard. The same server you write today works with Claude Desktop now, and ADK agent tomorrow, and whatever compliant client ships next quarter. No rewrite. You import your existing database clients and business logic unchanged. FastMCP handles the protocol. You handle the domain. Write once, connect anywhere.
So the one sentence?
Write a clean, typed, well-documented function. And FastMCP turns it into a tool any MCP client in the world can call.
The signature is the schema. That's the Datarekha audio guide. See you in the next one.